The universe is an ever-expanding marvel, a vast expanse that stretches beyond our comprehension. It is so immense that pinpointing its exact limit remains a challenge for astronomers and scientists. However, thanks to modern technological advancements, particularly the James Webb Space Telescope, we have been able to peer deeper into the cosmos than ever before. Since the telescope's launch, numerous scientific breakthroughs have been made, shedding new light on the sheer vastness of our universe. The renowned scientist Brian Cox and other astrophysicists have shared findings that highlight just how inconceivably large our universe truly is. Within the observable portion of the universe, estimates suggest that there are around 2 trillion galaxies. This number is based on observations of the local universe, yet it is widely believed that what we can see is only a fraction of what may be an infinite expanse. This notion alone is staggering. We are not merely distant observers of this grand cosmos. We are an integral part of it. In a sense, we are the universe becoming aware of itself, understanding its own intricacies through science and exploration. The James Webb Space Telescope has allowed us to embark on an extraordinary journey of cosmic discovery. If we think about traveling within our own solar system, the distances alone are mind-boggling. Imagine setting off on a journey at a speed of 70 miles per hour. At this rate, it would take approximately 15 days to complete a single lap around Earth's equator. Reaching the moon would take about 5 months. If we set our sights on Mars at its closest point, it would take an astonishing 63 years. And if we aimed for Neptune, one of the most distant planets in our solar system, the trip would last an unimaginable 4,400 years. These figures emphasize the sheer scale of our solar system. But to fully grasp its enormity, let's take a look at Voyager 1. Launched in 1977, this space probe traveled at an incredible speed of 38,000 miles per hour. Despite this velocity, it took Voyager 1 a total of 35 years to leave our solar system, finally entering interstellar space in 2012. Even light, which can circle the Earth 7 times in just 1 second, struggles to keep pace with the vast distances that define our solar system and beyond. However, even our solar system is just a tiny speck within the grander cosmic scale. Our home galaxy, the Milky Way, is a colossal structure that contains an estimated 300 billion stars. Each of these stars likely has its own planetary system, much like our own Sun does. The nearest star to us, Alpha Centauri, is located 4.3 light-years away. This means that even if we could travel at the speed of light, it would still take us over 4 years to reach it. Now consider the time required to venture even further beyond our stellar neighborhood. If we traveled at the same speed as Voyager 1, a mere 38,000 miles per hour, reaching Alpha Centauri would take an incomprehensible 70,000 years. This realization underscores the immense distances that exist between stars, demonstrating just how vast space truly is. When we extend our view beyond our immediate vicinity, the scale becomes even more mind-expanding. Take, for example, a star known as Vega, located 64 light-years away from Earth. If we consider what is known as the radio sphere, the distance our radio transmissions have traveled over the past century, our signals have only reached about 15,000 star systems. This might seem like a large number, but it is only a fraction of the estimated 300 billion stars in the Milky Way. Vega serves as a fascinating illustration of cosmic time travel. When we look at it in the night sky today, we are actually witnessing light that left its surface 64 years ago. This means that the light we now see was emitted decades before many historical events took place here on Earth. When considering the vast distances between stars, our entire civilization's history is minuscule in comparison. To put things into perspective, imagine shrinking our solar system to the size of a quarter. In this analogy, the Milky Way would be the size of the entire United States. The scale is incomprehensibly vast, and yet, our galaxy is only one among an estimated 1 trillion other galaxies in the observable universe. A trillion is a number so large that it defies simple understanding. To help visualize it, consider this. If you gathered 1,000 groups of 1,000 cats, you would have 1,000,000 cats. Now, if you multiplied that by 1,000,000, you would have 1 trillion. That's the number of galaxies estimated to exist in the cosmos. Our closest neighboring galaxy, Andromeda, is located approximately 2.5 million light-years away. It is heading toward us at a tremendous speed, and in several billion years, it will collide with the Milky Way. Despite the seemingly cataclysmic nature of such an event, the vast distances between stars mean that direct collisions between individual stars are highly unlikely. This reveals yet another aspect of the universe's immense scale. Galaxies can merge and interact without their stars colliding. Galactic interactions, while rare on an individual star level, can have profound effects on the cosmos. Such collisions can trigger new star formation and reshape galaxies over time. But even beyond our local galactic neighborhood, space continues to stretch endlessly. Beyond the Milky Way, we find our local galaxy group, which includes around 50 galaxies. This, in turn, is part of the Virgo cluster, which contains over 1,500 galaxies. And even this massive cluster is merely one component of the Laniakea supercluster, a vast collection of around 100,000 galaxies. But the scale does not stop there. Our supercluster is just one among millions of other superclusters in the observable universe. As we push the limits of our understanding, we encounter an increasing number of mapped galaxies. However, even these represent only a small portion of what actually exists. Many galaxies remain beyond our reach, obscured by cosmic expansion. The universe is filled with cosmic voids, vast empty regions where matter is scarce. These voids can span hundreds of millions of light-years and appear as gaps between galaxy clusters. They play a crucial role in the large-scale structure of the universe, shaping the cosmic web, a vast interconnected network of galaxies held together by gravitational interactions. These cosmic filaments, stretching across billions of light-years, bind the universe together. Within this intricate structure, galaxies congregate, forming superclusters of unimaginable size. Uniform but rather follows a web-like pattern where clusters of galaxies are interwoven by tenuous threads of gas, dust, and dark matter. These structures are fundamental to understanding the evolution of the universe, offering insight into the forces that have shaped its growth over billions of years. Supernovae, black holes, and quasars further add to the complexity of the universe. Supernovae, the explosive deaths of massive stars, scatter essential elements into space, contributing to the formation of new planetary systems. These cataclysmic explosions seed the cosmos with heavy elements such as iron, carbon, and oxygen, the very building blocks of life itself. Black holes, with their immense gravitational pull, influence the evolution of galaxies and release powerful jets of energy. These enigmatic entities warp space and time, consuming everything that crosses their event horizon. At the centers of galaxies, supermassive black holes exert their influence on surrounding stars and gas clouds, shaping the dynamics of entire galactic systems. Quasars, which are supermassive black holes actively consuming matter, can outshine entire galaxies, serving as beacons that illuminate the early universe. These luminous objects, powered by accretion disks of swirling gas, emit tremendous amounts of energy, revealing glimpses of the cosmos as it existed billions of years ago. By studying quasars, astronomers gain a better understanding of the processes that govern the formation of galaxies in the distant past. Despite our technological advancements, many mysteries remain. What lies beyond the observable universe? Due to the ongoing expansion of space, there are countless galaxies whose light will never reach us, making them permanently inaccessible. The relentless stretching of space itself causes distant galaxies to recede at ever-increasing speeds, pushing them beyond the limits of our detection. Some scientists estimate that the true size of the universe is at least 250 times larger than the observable portion, while others suggest it could be infinite. The idea of an infinite universe presents profound philosophical and scientific questions, challenging our perceptions of space and time. As we contemplate these staggering numbers and distances, we are reminded of our place in the cosmos. We are but a tiny part of a vast, ever-expanding universe, one that stretches far beyond what we can see or even imagine. And yet, through science and exploration, we continue to push the boundaries of our understanding, seeking answers to the grandest questions of existence. Our journey through the cosmos is far from over. With each new discovery, we unlock deeper insights into the nature of reality, expanding our comprehension of the infinite expanse that surrounds us. From the smallest particles to the largest cosmic structures, the universe continues to unveil its wonders, inviting us to explore its mysteries and embrace the endless quest for knowledge.